Hello, everyone, and thanks for joining us today for our webinar on water filtration and conservation. I'm Chris Miller, Inside Sales Manager of Institutions here at Partstown, and I'm joined by today's presenters, Steve Pytlak from Antunes and Mike Orlando from T&S Brass. Today's agenda includes two important topics, no matter the industry: water filtration and water conservation. Water filtration is essential for optimum performance of your equipment, as well as keeping employees and visitors safe. Whether you are working to achieve water efficiency or sustainability goals, or striving for LEED certification, today's webinar will help familiarize you with water quality standards and water conservation strategies. Before I hand it over to Steve, just a reminder that your lines are muted, but we'll be monitoring the Q&A chat during today's presentation. Feel free to type in your questions anytime throughout the webinar, and we'll address them at the end of the presentation during our Q&A. And now, I'll turn it over to Steve Pytlak, Product Manager at Antunes, for his presentation on water filtration.
Thank you, Chris. Hello, everyone, and thank you for joining us today. As Chris mentioned, my name is Steve Pytlak, and I'm the Water Filtration Product Manager with Antunes. Today, I'm going to go through some important factors to consider when looking at water filtration systems within your facilities. But don't worry, Antunes is here to make the process easy and painless. As I'm going through the presentation, think about your biggest filtration challenges that you're facing, and know that I'm here to answer the questions and provide a solution to your pain points. So let's get started. Here are a few topics that I'm going to go over. It's not a full list of factors, but it's just kind of skimming the surface just due to time constraints. When we talk of taste and odor in the water and particulates in the water, any type of scale or hardness reduction to protect any downstream equipment, health and safety, as well as total dissolved solids or TDS. So the first that I'm going to go over is taste and odor. So we know that over the years, municipalities have been using chlorine to clean the water. But what they've noticed is once it's combined with organic compounds, it actually can be harmful to humans. So they've started to switch. Some municipalities have been started to switch to chloramine, which is a chlorine and ammonia compound. So that allows it to last longer and to kill more bacteria that's in the water. So when we look at what is cleaning your water, that's going to determine what type of carbon filter that we want to incorporate into the filtration system. And that is going to be more of a chemical reaction within the carbon and to reduce your chloramine or chlorine. So that's one of the first things that we want to look at. The next is turbidity, or any type of particulates or sediment that may be in the water. On the screen, you could kind of see a low turbidity all the way up to a higher turbidity. It's really about how cloudy the water is. Without the proper filtration system, a lot of those particulates are going to go downstream and could get into your ice or even your beverages, and ultimately could make people sick, as well as cause any issues with your equipment. But any type of microfiltration or ultrafiltration systems would capture those particulates. So we want to make sure that we specify the appropriate filtration system due to the amount of turbidity that would end up being in the water. So this is a chart that shows a little bit of kind of the micron size of different particulates that are out there. The red line shows where your industry standard is, which is a 0.2 micron. At the bottom, you could kind of see there's a reverse osmosis, nanofiltration, ultrafiltration. 0.2 is around a microfiltration a filter, and everything to the right of that red line is what would be filtered out with a microfiltration system. Antunes does provide an ultrafiltration system, which is 0.015, so it would end up capturing a lot more of the smaller particulates in the water, but that is a discussion for, or a topic for a later discussion, so we'll go ahead and move on. The next is scale and hardness reduction. What normally happens when water changes phases, whether it changes to ice or into steam, the minerals, either calcium or magnesium, will drop out of the water, and it'll form scale. And what will really end up happening is your downstream equipment is going to end up working harder. The efficiency is going to be lower. They may increase any type of maintenance costs as well. So when we take a look at how hard the water is in the facility, we want to make sure that we have the appropriate hardness or scale reduction technology. And we're really talking about ice machines, coffee brewers, espresso machines, and then even in the kitchens when you talk combi ovens and different types of steaming equipment. So we really want to make sure that we take that and we get a good idea of what the hardness levels are going through the building. This is kind of just a graphic, kind of shows average water hardness throughout the United States. Even though you can look at this and kind of guesstimate what the hardness would be from state to state, we still want to take a water sample and test it, because knowing whether you're on a well or if you're using municipal water, the hardness is going to differ, whether it's from building to building, street to street, or even city to city within a state. So, but this is to kind of give a general idea of what the hardness throughout the U.S. is going to be. The next slide really talks about health and safety. So we talked about using chlorine and chloramine to kill bacteria in the water, but there are microorganisms that have a hard shell, hard shell around them and form a cyst. And if those cysts are ingested, they can make customers or people staying in your facility very sick. So we want to make sure that we have a filtration system that is going to capture, and that's a true mechanical filtration where the cyst will get stuck within the filter itself and capture, so it doesn't continue to go to the downstream equipment or water or beverages as well. The next topic, total dissolved solids. So there's a few different ways to look at total dissolved solids. The first is when we look at the EPA level, when you start nearing 500 ppm, you want to consider putting a reverse osmosis system in. Reverse osmosis is the only filtration system that can reduce TDS. But there's other things to look at as well. If you're like specialty coffee, let's say a Starbucks or a Dunkin' Donuts, they need a specific TDS dialed in. So their TDS levels may not be near the EPA limit, but they need it dialed in for that specific taste of their coffee. Something else to consider too is chlorides. If chlorides are high in the water, that can cause corrosion or pitting in any of your equipment downstream. So we want to eliminate that, as well as any type of scale formation, because reverse osmosis will also help with your scale formation as well. And then one of the final slides I have is all about talking about agency approvals. So when you're looking for a water filtration system, you want to make sure that it does have agency approvals and they conform to NSF 42, which is talking about the reduction of particulates and taste and odor, or chlorine and chloramine. But then also NSF 53, which talks about the health and safety. And that goes back to reducing the cyst and turbidity in the water. Now, there are other agencies that are out in the marketplace, Water Quality Association, WQA, or IAPMO, the International Association of Plumbing and Mechanical Officials. They also test and will give you a stamp of approval, but just know that when they do their tests, they are actually testing to the NSF standards. So they just may need to outsource some of that. But know that you want to make sure that a water filtration system meets those NSF approvals. But as I mentioned, those are only some or a few of the factors to consider. But again, I'm here and Antunes is here to help you select the appropriate filtration system for your facility. I'd also recommend taking advantage of our free water quality test. All we need is a pre-filtration water sample to really set a baseline of the water that's coming into your facility. And what we would then provide would be the results, recommendations of a filtration system, and then also we could perform that installation for you as well. Other than that, we appreciate your time, and I'll turn it back over to Chris.
Thanks, Steve. We appreciate your insight, and thank you all who have submitted questions so far. We'll be sure to address these near the end of the webinar. Our next presenter is Mike Orlando, Director of Sales at T&S Brass.
Thank you, and I appreciate everybody being on the call today. As Steve mentioned, water filtration is extremely important for all of the systems that you're using today. I just want to make sure that you have enough water to filter. So we're going to talk a little bit about water conservation. But first, just a note about T&S Brass. T&S is the last plumbing company left in America. We're the only ones who actually manufacture here in the United States. All of that is done in Travelers Rest, South Carolina. And we like to tell our customers that, we understand that they're not plumbers. We get that. You don't have to be a licensed plumber. We are. So if you have plumbing issues, you can go ahead and put those on us. We'll take care of it. So some of the things we're going to discuss today, we're going to talk a little bit about water facts. We'll go ahead and take a quick look at some specific water issues. We'll look at your typical facilities usage, how you're using the water today, and then some simple ways to conserve water and energy, and of course some operational savings. So here's how water works. There is a certain amount of water available in the world. The world is made up of 70% water, but 97% of it is salt water. There's only 3% that is fresh water, and of that 3%, there's really only 1% that's accessible. What studies have shown is as the world population goes up, the available water per person actually goes down. And people have a hard time comprehending this, but if you go back to your 6th grade science class, what you might remember is there is basically a finite amount of water on Earth. We're not making new water. It's how we use it that counts. This is called the hydrologic cycle. And again, the water comes down from the heavens, goes into the oceans and the land, evaporates back up into the atmosphere where it goes into the clouds and produces more rain. The cycle goes over and over and over again. Now, worldwide daily usage is about 10 billion tons per day. That's the average water use. And the average water use per person per day might shock you. In the U.S., the most industrialized nation, it's a whopping 152 gallons per person per day. And this is not just the water you drink, it's the water you use on a regular basis. So now you're asking yourself, well, how does this affect my facility? Well, it affects you in numerous ways. Rising water costs are one big way. The costs keep going up. And it's not just the water cost, but you have to remember when you're using water, you're paying for the water, you're paying for the energy to heat the water if you're using hot water, and you're paying the sewer cost. You have to get rid of that water once you've used it. There are stricter regulations coming down mostly from municipalities, but some from the federal government, and we'll get into that in a minute or two. And then there is that social responsibility to conserve water, and you're seeing it everywhere now. Most companies have a sustainability manager, sustainability officer, because not only is it a good thing to do, it's the right thing to do. So let's put some things in perspective. There's water usage we can't control, and there's water usage we can control. So here's what we can't control. We can't control industrial uses. We have to use water to make things like bed sheets, and it takes 2,800 gallons of water to produce one cotton bed sheet. That's just for one of us. Now, water usage we can control, you look at the average food service, it uses up to 29 gallons of water per meal. A running faucet during hand washing uses more than a gallon each time, and a lot of times, what you're going to find in a hand wash sink is that there's no aerator whatsoever. What that means is when you go to wash your hands, you're washing your hands at the full force of what the faucet will bear. Sometimes that might be 6 to 8 gallons per minute. If you have shower heads in your facility, a lot of shower heads, if you haven't changed over to low flow, those shower heads are using 4 or more gallons per minute. And if you have teenagers at home, you know that those showers can last up to half an hour. Not such a good thing. And back in a commercial kitchen, an older pre-rinse spray valve use as much as 4 to 5 gallons per minute of water. All right, so let's look at your facility. Opportunities for water conservation are everywhere. If you look at a kitchen or dish room, you have a number of things that you're using, hand sinks, pantry faucets, dipper wells, depends on the menu actually. If you look at the restrooms, you always have a lavatory faucet. You may have a sensor or an electronic faucet, but all of them should have an aerator on them. In patient or guest rooms, there's always a hand sink with a lavatory faucet. You have bath and or shower valves, and again, aerators. In the maintenance room, which is the area most people forget, there's generally a hand sink because your maintenance person needs to wash their hands. You have a pedal valve or a service sink faucet. If you look in some of these areas, you're going to notice that there are typically a lot of leaks in there. The maintenance department is often overlooked and people concentrate on the rest of the facility. And then in cafeterias and ballrooms, there's typically something outside of the actual ballroom where the folks who work there can actually wash their hands. And don't overlook your conference rooms. Many conference rooms have sinks. They're not used on a regular basis, but they still are required to be maintained. So the first step to reducing your water consumption is to actually know what it is. And in order to do that, we can do a water audit. We look for the greatest areas to improve. So back to your kitchens and dish rooms, the biggest source of savings is going to be your spray valve. The pre-rinse spray valve operates, the older valves operate at 1.6 gallons per minute or more, but there are newer valves available. A B107J, for example, operates at 1.07 gallons per minute. An ultra-conservative low flow is our 107-C, which operates at 0.65 gallons per minute. And with these, if you make a simple change, which actually doesn't cost a lot of money, that simple change can save over $3,000 in water, energy, and sewer costs annually. It's more than enough to pay for the new equipment. So wouldn't you trade $100 to save more than $3,000? I think you would. One thing you have to understand, and this goes back to what I said before about regulations and restrictions. The Department of Energy last year got this passed, but after January 28th, 2019, all pre-rinse spray heads being sold must be less than 1 gallon or 1.2 gallons per minute. It is the law, and so you will not be able to buy a high-flow pre-rinse spray head. Now, that doesn't mean that it's not going to do a good job. The newer spray heads that are coming out, even the ultra-conservative low-flow ones, do a fantastic job at cleaning. They use less water, but they're much more efficient. And to give you an idea how efficient they are, we normally run this test, and this is something that we can make available to you. You can watch these videos on YouTube, but we actually show older style spray heads versus the new spray heads. And you can see a dramatic difference in how much water you're using. Part of our water audit, we can actually run the information through a calculator, and these are all available on our website. And you can plug in the values for the existing spray head that you have, and then look at options on newer spray heads, and this will tell you exactly how much water you're saving, how much energy, and what it's going to save you in your sewer cost. So other market segments that we're looking at, T&S does a fair amount of business with schools. We're the #1 spec for most school districts. Grocery stores where you have numerous departments. We typically look at chain restaurants, but in a grocery store, there may be up to 10 kitchens. And in healthcare, whether it's hospitals or senior living or surgery centers or whatever, you generally have a kitchen, surgery prep, patient rooms, and restrooms. Another way to cut water use by up to 20% is to move to ceramic cartridges. Ceramic cartridges have been around for more than 10 years. Those ceramic cartridges save as much as 20% of the water that you're currently using. The secret here, though, is to go, if you're changing from a brass compression cartridge, the older style, that has numerous parts, and you move to a ceramic cartridge, you really want to change both at the same time. The good news is these cartridges offer a lifetime warranty, so it should be the last cartridge you'll ever need to replace. That'll save you money in the long term. On hand sink faucets and non-fill areas, we're always looking at aerators, and here's why. Hand washing is not an option. In healthcare, in food service, you have to wash your hands. This is how we protect the public. And so hand washing is not an option. You have to do it, but that doesn't mean you need to wash your hands at 6 to 8 gallons per minute. A low-flow aerator will actually save a tremendous amount of water. And again, when you look at some of the studies and some of the examples that we've shown at trade shows and at customers' facilities, it's a dramatic difference in the amount of water that you're using. Back to the hand sinks, there is always the pedal valve. The pedal valve works really well in an operation that you want to have a mechanical solution to be hands-free. So if you can't really afford an electronic faucet, a pedal valve is a good solution because you step on the valve and the water starts to flow. When you let up on the valve, the water stops. And so the water is not running the whole time you're washing your hands. On sensor faucets, if you want to go the route of an electronic or a sensor faucet, those sensor faucets save up to 1 gallon of water per hand wash. Remember, the water is not on when you're not washing your hands. As soon as you take your hands away, the water stops. And people's reservations about electronic faucets are typically because they don't have any place to plug it in. Well, we have an answer to that too. The hydro generator actually powers the electronic faucet on the incoming water supply. That means you never have to change batteries and you never have to plug it in. So it's the perfect solution, and it's a very green alternative. If you have showers in your facility and you haven't looked at how much water is flowing through the showers, if you replace a high-flow shower head with one of the more efficient versions, you can save up to 50% in the water that you're using. So again, you're not paying for the water, you're not paying for the energy to heat the water, and you're not paying the sewer cost. In guest rooms, you have to start to look at things that you can't control. You can't control the movements of your patients or guests. So you want to start to think about what the performance of those products are, and also take into account guest satisfaction and reliability. Service sink faucets are used in just about every facility. These are typically tucked in a closet where you're keeping your mops and your brooms. These are generally a source of leaks, and just a quick note, if you're using a chemical company and that chemical company comes in to put a chemical dispenser next to your service sink faucet, typically they screw on a brass T so that you can have water powering the detergent dispenser or the chemicals. The other side goes to a hose that actually you use to fill your buckets. The problem with this is nobody ever turns off the faucet. They control the water off that T or that Y. So it's a good practice to go ahead and turn off the water at the handles when you're not using it. And that'll save a tremendous amount of parts, because if you build up pressure, you have a chance of the vacuum breaker going and also the cartridges. All right, so here's the payoff. When you switch just one spray valve, you go from a high flow to a low flow, you can save more than $3,000 a year in water, energy, and sewer costs. That's just one area. Here's the other big area. It's time to fix the leaks. Every time you see a drop of water coming off of a faucet, you're wasting money. You're wasting a lot of money. And it may be up to 71,000 gallons per year. So it's always a good idea, and this is something that your maintenance people should be attuned to. So water is really a critical source. We really need to protect it and do all we can to manage that in your facilities. Choosing low-flow products is really only one piece. You really need to consider whether or not you've trained your employees properly. So if the employees understand what the objectives are, most of them will get on board with this. So our recommendations are really to implement plumbing codes that restrict flow and rates on both residential and commercial products, and typically it's everything that you're using today. And then convert existing facilities over to low flow by changing specs on all those new facilities. In summary, water shortages are, exist today. They're going to worsen, and the cost for water and energy and sewer will rise. There's opportunities everywhere in your facility to save water. You just have to look for them. You need to consider the product quality and the life cycle. And saving water actually helps towards sustainability goals, but also saves you a significant amount of money. And you really just need to overcome the paradigms and become part of the solution. It's up to everybody now to conserve water. We don't want to get to a crisis stage because at that point we're all in trouble here. So again, I want to thank you for joining us today. If you are looking for additional resources, we always have these on our website, or you can talk to the folks at Partstown here, and they're more than happy to send you out as much information as you can handle. Thank you.
Thank you, Mike, and thank you to both of our presenters that joined us today for today's water webinar. Looks like we have a couple questions that have come in here that I'll ask aloud. One of the questions that came in was related to the water testing. Can we cover explaining the process for that free water test?
Sure. So Antunes can provide a container and all the necessary items to send out to the customer. Normally, we like to do a pre-filtration water sample, which would be maybe a mop sink or a sink in a restroom. Send that in. We test it internally in our lab. But there's also another part of it. If there's currently a filtration system installed, we'd also like to see a post-filtration sample, because then we can compare the pre and post and really see how effective their current filtration system is. And if there are issues, we could provide recommendations or even a new solution as well. But that pre-filtration really gives us a baseline of what the incoming water to the facility is. And once again, it's free. So, you know, as I mentioned earlier, I'd recommend just kind of seeing where the water is that's coming into the facility to make sure you have the necessary filtration technologies to protect the equipment, as well as any patrons or customers that come into the facility.
Excellent. Thanks, Steve. Another question that came in was related to restroom use of aerators and what aerators should be used in those spaces.
Well, the current plumbing code is 0.5 gallons per minute, so a half a gallon per minute for public restrooms. That doesn't mean you have to limit it just to the public restrooms. If you can use a half a gallon per minute for the general public, you can also use a half a gallon per minute in the back of the house facilities as well. So, you know, where your people are actually washing their hands. So again, it's a good thing to do.
Great. Thanks, Mike. Another question we have here that's come in is, how do I know if I'm specifying the proper filtration system for my capacity?
So what we'd like to look at is what equipment the water is feeding. So for instance, if there's an ice machine, a coffee brewer, and a fountain beverage machine, we want to look at the maximum capacity of each of those pieces of equipment, because if each of those is drawing water at the same time, we want to make sure the filtration system can withstand that capacity. So it's really about looking at all of the equipment that it needs water, and then really taking a look and speccing out the size or the type of filtration system that can make sure that all of that equipment is getting proper water to it.
Great. Thank you, Steve. Looks like we have one more question here in the queue, and that is related to how do I do a water audit for my facility?
Well, doing the water audit is a fairly straightforward process. What we'd encourage you to do is contact the folks here at Partstown to go ahead and set that up. But it's actually a no-cost value-added service for our customers. And typically what we do is we come in, we'll pick a day at your facility, we'll come in, we'll measure all the water, we'll check the efficiency of your operation, we'll talk to the folks who actually work there to get a pretty good picture of how you use the water and where the problem areas are. When we measure all the flows, we look at that versus your menu or your operation to make sure that we're doing that in the most efficient way possible. There is newer technology available today that might not have been available 10 or 20 years ago when the facility was built. But updating that equipment, becomes a matter of choice. At the end of the water audit, which there's typically a very nice comprehensive report, you will have a laundry list of recommendations. All of those recommendations are meant to offer you some savings or some better options in terms of what you're using. But it takes just a day to do the audit, sometimes less than an hour, and you'll get a nice report that you can work with the folks at Partstown to get the replacement equipment.
Thank you, Mike. All right, thank you all again for attending our water webinar today, hosted by Partstown. On your way out, you will receive a short survey. Please let us know any thoughts or suggestions you may have so we can learn more about the topics that are relevant to you. Your feedback will also help us determine if this is the best format and schedule for future events to best meet your needs. Also, we will be sending out a copy of the presentation and the Q&A as well for all of you to reference at your facilities. Thank you again to all of our presenters for your time and valuable information today. And with that, I'll close with everyone. Have a great afternoon.